Hi again. My name is Huseyin. I'm a software developer. So in this session, we will mostly talk about JVM, Java. But before start, I am doing software development since 2007. I started as a freelancer. I have used different language, PHP, and after 2010, I worked for big companies like Sony and eBay. So my main responsibility was to involve in the DevOps and microservice transition projects. So after 2016, I started to work remote, and after that time, I'm mostly building Kubernetes-based products, and I mostly use Java and Go in that environments. And recently, we are building a software as a service project. Again, it is a Kubernetes product. So I am doing regular Twitch streams. You can see me on Twitch with my username. And time to time, you can see me on YouTube. So JVM, Java Virtual Machine. It is not a different thing other than other application. For example, Chrome, Firefox, Spotify. When you take a look at your activity monitor, you can see there are a dedicated process for them. JVM is another process. So you basically start a Java application and it is run on a JVM, Java Virtual Machine, and you can see the specific process ID for that. So another process. When you use JVM, it enables us to run your Java application in most of the infrastructures. So you implement your application for the first time, and you can run it on Linux, macOS, or Windows, or other server instances. So maybe 10 years ago, most of us mostly has this one instance of Java application, right? So we don't have microservices, we don't have containerized environments. Of course, there can be multiple replicas. Let's say that you have a load balancer, you can have multiple instances behind this load balancer, but most of the time we have only one or two instances. So monitoring or just take a look at what's going on in the JVM. Maybe compared to this one, it was very simple. But right now, when you say, I have a Java application, then you might need to think about you can have multiple replicas. Even since you divided your monolith application into microservices, you have lots of JVM instances. So this is why we need a JVM profiling, right? So basically, we gather information from the system in order to do, for example, performance analysis or troubleshooting of a bug. Assume that you have a memory leak, you want to troubleshoot that one, or there's no memory leak, but you just realize that in the lunchtime, your application response latency just becomes bigger than usual all the day. So you need to just take a look at what's going on there, just do a performance analysis on top of your JVM. For these kind of purposes, you need JVM profiling. In order to do profiling, you may need to be familiar with a couple of parameters. Of course, if you ever used Java before and maybe configure an application in the remote servers, you know the basic parameters like XMX, XMS for your heap configuration. But let me introduce a couple of more different parameters for JVM, different options. For example, here, the print compilation, we are seeing that JVM application, the memory management is very good in Java, JVM. Here, there is a term which is called JIT compiler, just-in-time compiler. Java, time to time, does just-in-time compiling operation during the application runtime. So if you want to know when this JIT compiler just does its job, you can use this option. When you edit, you will see additional logs in your Java application output. Print GC, of course, during the troubleshooting or during the performance analysis, let's say that you want to see when the GC, garbage collection events happened for a specific time interval. You can take a look at, for example, last 1 week, and you can take a look at the GC events. Here, there is another parameter which is called print GC detail. So it is nearly same with the print GC, but you can see more details about GC events. So maybe if you want to only know when the GC happened, you can use the first one. But if you need more details, then you can use print GC details. Of course, you need to pass this part of JVM options during the application startup time. Print GC application stop time. Whenever this GC happens, there might be a stop. Stop the work within your application. Maybe you may want to see this detail also to show application pause time. Let's say that if you have big pause times during the GC events, then you may need to think what's happening there. Print heap at GC. Here, print heap information before and after GC. So this is also very important, right? Because, okay, you are able to see when GC occurs, that's fine. But if you know the heap size just before and after GC, it can help you to understand what's going on there. For example, you have 200 megabyte of heap before GC, but after GC, you realize that 200 megabytes is not reduced. So you need to think about that there is a memory leak there, right? That there might be a possible memory leak. GC just is being executed, but there is no change in the heap memory. Or you have 500 megabytes heap before GC, and GC is executed, but it is reduced to something like 490 something. So there might be another problem also there. So before and after GC information is very important in this case. Print tenoring distribution. So you need to have a bit more JVM information here. This tenoring information, it shows the aging distribution of the object in the heap. So you can understand which object category has how much age in the JVM. A couple of more. Unlock diagnostic VM options. So we will talk about the profiling, but this kind of profiling tools just needs additional information from JVM. So here, the first option has profiling tools that rely on the JVM save points to produce more accurate results. So there is some points in JVM, which is called save points. And in these points, it is safe to just stop all the threads maybe and do the operations. So if JVM provides me this information, I can easily, since the threads are stopped, I can easily collect a couple of information. I can get more accurate results. So if you enable this option with this JVM option, and we will use a sync profiler, for example, we will get more accurate results. Debug non-save points. So there is save points, and as you guessed, there is also non-save points, the opposite of save points. Maybe you may need that information also. Just enable this one if you need. Always pre-touch. This is normally when you run your application, the JVM creates a heap area for you. For example, 500 megabytes. There is a heap memory for you. It is reserved to your JVM process. So, but if you want to use any kind of data structure in your JVM, you will see they are first reserved in the logical memory in your JVM. But if you want to just reserve that area also in the physical memory, then you need to use this always pre-touch. So basically, it will prepare all the area for you, and there will be no cost for moving your data from logical virtual memory to physical memory. So this is also used during the profiling operation. So until this point, we talked about a couple of JVM options and what is JVM. Now we will deep dive a couple of more comments to understand how to collect our information to continue with the profiling. We already said that it is just another process, right? In order to list all the JVM processes, you can use JPS command. If you already have JDK in your environment, you can just, this command is available to you, JPS. It lists all the instrumented JVMs in the target system. We are saying target system because maybe you connected to instance in the remote via SSH, and then you just wanted to list that one. So since you know the ID, process ID, now you can do additional operations. For example, heap and thread dump. For heap dump, what is heap basically? JVM creates a heap dump during the application startup, as we already said that. it contains the reference to live objects that is created by Java application. So you already have a code base, it is creating objects. Maybe you are, for example, manipulating a list, you are adding a couple of items to an array list. You can understand that all the, for example, references are during the function execution, they are all located in stack, but the real objects, they are located in the heap. So JVM creates this one, heap dump. If you take the heap dump, this heap dump file will contain the saved copy of the objects used at runtime. So your application is running, you created class, you created array list, you created a cache in order to store your items. They are all located inside heap. And then when you take a heap dump, you will basically take a snapshot of your heap. And it will be available in heap dump file for a specific time. And thread dump contains snapshots of the thread in running Java program at specific time. So why there is this different operation for thread dump? Because when you say heap dump, okay, it contains live objects, but when you take a look at the thread dump, they all have their specific locations, right? All the threads, they have their stacks, and then they have some kind of available memory. When you say thread dump, it will prepare a special file for you, so you can just take a look at what's going on. How many threads do we have at a specific time? Maybe if there is a thread lock, you can also detect by using that file. There is also a third one, which is core dump. I will not talk about core dump in this session. So if your application can do any kind of native OS calls, and you can also analyze, you may want to analyze that one. So you can do core dump instead of heap of thread dump for this case. But this is out of context. You can understand that there are three kinds of dump operation in a specific JVM world, let's say that. So assume that I am in my local computer. I have a running application. I just wanted to take a heap dump. By using command, if you have JDK, you have JPS, assume that it returned 7,000 as a process ID. In order to take heap dump, you can use jmap command. Here, I'm saying that with jmap, just dump the heap. I am saying leave here, whatever we have at the current time. It will take the heap dump and it will be located inside the provided file path, tmp, hdump, hprof, and you are providing the process ID. So it will just take the heap dump of the JVM that is located in this process. There's a very, very popular tool in this area, which is called Visual VM. So in Visual VM, also visually, you can see the process list on the left-hand side. I will show you in a minute. Once you click on it, you can see different kind of options. So when you click on the monitor, there's a heap dump section there. You can click heap dump and you can save the file in the specific location. So this is the second way to take the heap dump. But maybe you have a question, right? Reasonable question. Yeah, I can manually take heap dumps by using Visual VM, by using command. But in the production, in real life scenario, I am not able to do that. So I don't know when to take heap dump. Just, it is not visible. So there's an answer for that. You can configure your JVM options in a way that if there is nearly an out-of-memory error, the heap dump will be automatically taken by the system. So if you add those two parameters, heap dump on out-of-memory error, if there is an out-of-memory, JVM will automatically take a heap dump for you, and it will be located under tmp heap dump hprof. So you need to be careful about this. If you are using bare metal, you have a virtual machine maybe, and this file will be located in the disk, let's say that physical disk inside the virtual machine. But if you are in a containerized environment, and this file will be located in the container, but if you have out-of-memory error, most probably your pod will be restarted, and then your file will be gone if it is under TMP folder. So you need to be careful about enabling the persistent volume claim for your application. Maybe you can use stateful set. Even you have used deployment, just don't forget to use this kind of volume to access this heap dump file in the future. So it will be automatically taken for you. What can you do with this file? I will also show it to you. You can just use Visual VM or other tools to analyze what happened in your JVM. So there is no problem with the memory. That's totally fine. But you have a performance problem in your application, and you may want to take a look at a couple of things. And this thread dumps is one of them. Maybe there is a problem with the threads. Maybe there is a lock, right? In order to take thread dump, you can send a kill -3 command. This is called sig quit. If you, for example, if you say kill -9 the process ID, of course it will kill your process. But if you say kill -3, there will be a special signal which is sent to your application. Then it will automatically take the thread dump. So there is a signal handler inside your JVM. If you send -3, you will see it will automatically take a thread dump for you. This is useful for maybe remote environments, also your local. You can just try this if you like to use command line notation. Also, you can use JStack additional parameter, but this is just an example to that. You have a heap dump file. What is next then? You can use Visual VM. You can use Eclipse. There's another tool which is called Eclipse Memory Analyzer. You can just import this HPro file into Memory Analyzer, Eclipse Memory Analyzer, and you can take a look at that. What is inside heap? What is the class distribution? What is the, for example, what is the biggest item in your JVM? You can just take a look at this kind of operations, useful insights. And about a couple of more examples to thread dump. Here you can use JStack. When you say JStack, it will print the thread information into your system output. But if you redirect it to a specific file, you can use this greater than and define. So all the thread information, thread dump, will be available for you to be used in the future. Also, another option, you can use JCMD. With JCMD, basically, of course, the first parameter is the process ID, but the second parameter can contain different kind of things. For example, you can just trigger garbage collector operation. You can take a heap dump. You can take the thread dump. You can send lots of commands which is available inside your JVM. So basically, function which is implemented in JVM can be triggered from remote by using JCMD. There is an API, and you are calling this API method by using JCMD. What about Visual VM? In Visual VM, same notation, there is a tab which is called threads. You can take a thread dump. Once you do a thread dump, on the left-hand side, you see there are lots of thread name, right? If you create your own thread, do not forget to just provide a name. It will be useful for you to analyze it further, because here, all of them mostly related to system. You see attach listener, and JMX, JFR recorder thread, notification thread, main thread. Even you are not using thread, there is a main thread there. So if you want to differentiate your threads from the system threads, you can just, of course, there is a parameter in the threads. You can say that this is a system thread or non-system thread. But here, if you provide a meaningful name to your threads, it will be easy to just analyze it in this kind of tools. So what you see until this point, they are all available in JVM, JDK, so you can do basic operations. But there is another tool, which is called Async Profiler. Async Profiler is low overhead sampling profiler for Java. So you have a running application. This project, this library just helps you to sample your application. So just collect the samples. There are lots of parameters that you can configure, but basically it can track CPU cycles, right? It can do hardware and software performance counter like cache misses, branch misses. They are low-level terms, but for example, it can trace the allocations in Java heap. when you execute async profile command, I will show examples for that. It can just analyze the allocations for you in the heap, and it can also generate a flame graph for you to understand what is the distribution of the objects. And also you can do the analysis of logs inside your system, JVM. Once you download this async profiler from GitHub, there is an available command profiler sh, but there is also additional project which is AP loader. So basically, you don't need to move sh file from one location to another, put it under your system path, and make it available to your computer. But also, there is an easy way to use that AP loader. I am using the very early access build, which is 3.0. And there is another easy command for that. So we will see it in a second. But basically, if you use async profiler, you need to provide an event first. For example, here I am saying that I need to do allocation profiler for this process. Allocation profiler means I want to see the insights coming from JVM heap distribution. So how many items or what is the status of my heap? If you say CPU, this time it will track your CPU cycles. Maybe you have a problem. So you are doing an image processing or you are doing a matrix calculation, right? Matrix multiplication. This kind of operations just overloads the CPU, right? This time you may want to do a CPU cycle tracing here. Also, there is a vol clock. So for example, in CPU cycles, time to time, CPUs might be idle, right? It can be idle time to time. For example, during the file operations or during the I/O calls, there might be an idle time for the CPUs. You may introduce some kind of concurrency operation. If you do CPU profiling, you will see that your application was running for 1 hour, let's say that, but the CPU time is something like 40 minutes. It can be. But when you say vol clock profiling, that means it is the time that your application is running. So you started your profiling, you just take a look at your clock, and then when you stop the profiling, you take a look at your clock again, and you just simply subtract those times between each other. That's it. Allocation is about memory. There is also additional one, for example, clock, and there's one more, but I haven't used it in none of my production applications. The D parameter is duration. You can say that just trace my application for, I don't know, by default it is in seconds. You can say that for 10 seconds, profile my application. For 30 seconds, just profile my application. And just put the result in this file, which is provided by -f. The final parameter is, of course, process ID. When you say JFR means that Java Flight Recorder, you know, all the airplanes that has their plane recorders, flight recorders. With same reason, we also have JFR here. Your application is running, and then when you profile your application, all the traces will be put inside this file. But you need to have a special tool to visualize this JFR file. But if you provide an HTML extension, then you will see this flame graph will be automatically put inside this HTML. You can just open it in your browser. We will see it. And in AP Loader, it is the easy way of using profiler, async profiler. But in AP Loader, other than profiler, there is additional command. We will also see that one. For example, there is converter, there is profiler, this kind of utility tools. Just they are bundled inside the AP Loader. So what about in Kubernetes environment? So I will show you demo. It is mostly with Spring Boot application. It will be inside Kubernetes environment. I will also show it in my local. But if we are inside Kubernetes environment, what to do specifically for Kubernetes environment? Assume we have a Spring Boot application. We can just take a look at these four items here. Enable actuator for JVM operations. Of course, this should be enabled inside your network, not outside for the outside. It shouldn't be accessible from public network. Here, if you have ever used actuator before, Spring Boot actuator, you can see you can enable a couple of extensions by using that one. For example, you can just take a thread dump by using actuator endpoint. There's a special endpoint for that. When you make a GET request to this endpoint, you can just download the heap dump file into your local computer. Also, I am using Prometheus Micrometer. So, this is the de facto project in Spring Boot 3 Plus for providing useful insights about your Spring Boot application. So here I'm using Micrometer Prometheus registry. So basically it will generate Prometheus-like metrics for your Spring Boot application. There will be a special endpoint for that. You can also add continuous profiling. I have showed you one command for async profiler. There is a special starter project for that. If you add that starter project into your Spring Boot application, you will see it will automatically profile your application for a specific time interval. You can configure it in the configurations. And of course, inside the Kubernetes environment, I assume you have Docker image, of course. And in Dockerfile, you can inject the async profiler so that whenever you jump in one of your pod, you can do async profiler commands. You can execute them just inside the pod if you need. So in JVM operations, by default, you cannot access these endpoints when you use actuator. You need to expose them. For example, heap dump, thread dump. If you enable them, you can access your application by using thread dump or heap dump. Once you do that, you can just download these files, heap dump and thread dump. In the Micrometer registry, you can just define a configuration bean like this. It is basically your application name. If you provide this one in the Prometheus metrics, you can easily differentiate metrics by using application name. We will also see a demo for this. For the continuous profiling, I mentioned already a starter project. This is the starter project. When you add that, you will see during the application startup, it will be enabled, and then it will do the profiling for you in the production environment. So you're saying, why do we need such a thing? Because the error can happen in any time if you have async profiler in the continuous in the loop mode, and then maybe you may catch this heap, for example, allocation. In allocation mode, you can just take the information from a heap. Then you can understand, oh, for this reason, we had this bug. You can easily understand that one. But this is not a must-have project. For example, you have a performance problem in your production environment. At that time, you can jump into your system and you can take a heap dump, or you can do async profile operation. It is just up to you. You need to, you are the best that can understand your environment. You can choose any of the notation. I need to focus on a bit this Docker file. So in Dockerfile, we were using OpenJDK, and there was an adopt OpenJDK in Docker Hub. But after a specific version, as far as I remember, it was 11 or 8, I couldn't remember correctly. They're just promoting another projects. Amazon Corretto is one of them. So I'm using Amazon Corretto in my Docker files. So here, you see, I am adding curl, tar, and lib C++ standard library here. In async profiler, I am simply downloading this asset and then putting it into the system path. So async profiler will be available inside system path. I can execute it anytime, whenever I need. This was a multi-stage build. I am copying my jar file. Also in Java 2 options, I have enabled JMX configurations because I needed to do some kind of connect to remote JVM instance and just take a look at what's going on there within the visual VM. I can also do that. And the final line is entry point, of course, Java-Java. So assume that you have 10 JVM application, and also they have 3 replicas. When you multiply them by 3, you will see you have 20 JVM instances inside your Kubernetes environment. So naturally, it is not easy to just take a look at what's going on there. Since you are inside the Kubernetes environment, you can use the de facto tool for monitoring, which is Prometheus. Helm tool, most probably you have heard about that. it is the package manager for Kubernetes, one of the package managers. Here I am installing Prometheus stack that contains Prometheus, Alert Manager, Grafana, Service Monitor, this kind of things. And inside monitoring namespace. When I install monitoring stack here, I will have a Prometheus instance, and also I will have Grafana dashboard. Also, I have Java applications, but this stack cannot automatically just discover and then just monitor my endpoint. So here in service monitor, this is a custom resource definition coming by, with the Prometheus stack. I am saying that, okay, could you please create an additional service monitor for me with its name Spring Boot App Monitor? And in order to discover my application, you need to use these labels, Prometheus monitoring true. It is located inside default namespace, and the endpoint is HTTP actuator Prometheus. Remember that I have used Prometheus registry, and it is available inside actuator Prometheus. This service monitor will be visible inside Prometheus targets menu, and then it will start to collect my application insights. So basically, it contains JVM insights. And I already said that there is a Grafana stack there. Since I have monitor for my Spring Boot applications, there will be all visible in Grafana dashboard. I will show you the full one. So I will do the demo for 5 or 10 minutes. And let's take a look at what we can do here. So this is my Java application. I will simply run it. So this is an application. And in this application, I prepared a couple of endpoints like leak count, I/O, just simulate the I/O operation, and CPU. Yes. So what can I do? Let me try to do something like this. I already said that AP loader tool, right? You can install it. AP loader. I am saying that profiler start, right? In profiler start, I want to do allocation profiling. Allocation. The file, let it be 5. And here, I don't know the process ID, right? Let me stop this, JPS. You see, my application is demo application. And just copy this one. Okay. Okay. So it will start the profiling. Now it is profiling. I will do some kind of endpoint. So I will hit the leak endpoint here. Let me do that a couple of times. Okay. Like this. And also, I can take a look at my local host, AP81 actuator Prometheus. Here, you can see there are lots of JVM related stuff. So they are all available inside. It will be available inside Prometheus. So I did a couple of this. Let me just hit a couple of times like this. And then I will stop the profiler. The process ID was this. So started the profiler, just did a couple of operations to manipulate heap, and then stop the profiler. Now I will open a log5 HTML. Okay. So here, you can see, so let's say that there is a memory leak, and I am trying to analyze it, what's going on there. So when you take a look at the flame graph here, you will see, oh, our favorite guy is byte array. So maybe you can take a look at further here. The 63% of the usage is caused by this byte array. And you can see the second item is leak controller leak method, right? So if there is a memory leak, you can understand that even you can filter something, because there are system classes also. But here, you can just do a filtering demo, for example. It will be highlighted automatically. You can take a look at that one also. So you can try to find who is causing this kind of problems in the system. Since I did an allocation profiling, I can see allocation related, let's say that flame graph. And so this is one usage of profiling operation. You can also do something like, let's do start again, but this time you can say CPU allocation. I will do 6 this time. And I will do CPU related requests. In CPU, I am trying to generate a random number. You know, random number is a mathematical calculation. When you think about mathematics, then you can directly map it to CPU because there's a calculation. So if you multiply metrics, then you need to think about there will be a CPU overload. Let me do a couple of times and stop. I couldn't remember, but I hope it is the correct one. Okay. This time, you see, since I was doing in control task run, I am doing a random mathematical calculation. So I can understand, okay, this one is hardening my CPU. I need to focus a bit more on this one. So what can I do with random number? Maybe you can come up with, I don't know, just a crazy idea. You can come up with possible values inside a file or database. Let's say that 1 million items. You can just take one of them, just an idea, instead of trying to calculate this one again and again. If you are doing, for example, symmetric cryptography operations like crypt-decrypt by using RSA, then it will also harden your CPU. So you need to be careful about that. So when it comes to example here, CPU, I need to stop my application. Okay. So here in CPU, what I am doing is I'm creating a thread. Inside this thread, I am trying to do a random calculation here. That's it. So you can just take a look at the flame graph, focus on the part, and then try to refactor this part. For the memory leak, what I am doing is in leak controller, there is an instance variable. I am continuously adding 1 kilobyte to this array list each time. So since my application is up and running, since the leak controller class will be available until I stop the application, then this leaky storage will never be garbage collected because this is live here. I added lots of items there, so they will not be clear, and it will cause an out of memory error at the end. So you can also detect that one. What about in Kubernetes environment? So in Kubernetes environment, you can enable this async profiler, and then let me show you an example for that. This is my Kubernetes environment, demo environment. Here, there is a Spring Boot application. When I SSH into this application, this pod, okay, under logs continuous, as you can see, I have JFR files here, right? So since I enabled continuous profiling by using async profiler, I can see my historical Java flight recordings here. You can download them and then just import it into Visual VM. It is same. So once you set Visual VM, let me also show an example for that. While I'm opening that one, Prometheus, let me try to open this one. So this is the Grafana dashboard for my application. here in the dashboards, JVM micrometers, let me do a couple of zoom last 5 minutes. So as you can see here, that's it. So here, the IP address of my pod is 107, ends with that one, 107 here. So my application is up and running for 6.5 hours. The heap usage is 23. Let me increase it a bit more. Increase it a bit more. Here, it should be this one, milk. I hope this is the correct one. Okay. So this Grafana dashboard is very important because you have a clear eye on your the entire system. So you see the heap is increasing here. You can also see the distribution in this phase JVM. You see the usage is increasing here. I can see my XMS and XMX. I can see the CPU usage. There is no real CPU usage right now, but if I do call the CPU endpoint, you can see the spike here. You can see the JVM memory pools in heap. There are lots of useful information here, and this dashboard is a community dashboard. You can directly import this dashboard into your Grafana instance. So that's it. I see my overall system. I have only one application, async profiler, but in real case scenario, if you have 100 applications, JVMs, you can see them all here. When you select one of them, you can see the heap, the JVM inside this dashboard. I think that's it about the entire system. Yeah, I can, if there is any kind of question, I can happily answer them. And other than that, thanks for listening. I hope it was a valuable session for you. And yeah, thank you for listening.
All right. Thank you very much for your input. Maybe there are some questions remaining. We can just have a little bit more time to answer them.
Yep. I see one question. Can I run heap dump without triggering GC? They are totally different things. When you trigger GC, so there is no guarantee to trigger a real GC, by the way. You can trigger GC, but it is directly related to JVM, and JVM will plan to run your manual GC. But GC is used for just clean up your heap memory, and there will be, if there is unused object, they will be automatically cleaned up, and there will be more memory in your heap. But in order to take a heap dump, you don't need a GC or something like that. Just trigger the heap dump. Even you don't have anything inside your heap, you will have a small file, something like that. But GC, heap dump, they are totally different things. You can trigger heap dump, just they are not related to GC.